Hi, everyone. Thank you for joining today's webinar on leveraging smart manufacturing and advanced analytics for continuous improvement. This is the first of hopefully many joint webinars between Grantek Systems Integration and Seeq Analytics as we work to educate the manufacturing community on how you can leverage some existing and new technologies to help improve your business. My name is Sam Russem. I'm Grantek's Director of Smart Manufacturing, and I'm going to be guiding us through the webinar today. As for our agenda, we're going to be starting off with some brief introductions for the webinar team, Grantek and Seeq. Then we're going to talk about some common challenges in the industry and that analytics tools can help to address. And after that, I'm going to hand it over to Brian to demonstrate some Seeq use cases, and we'll have some time for questions as we close out. So I've briefly introduced myself. Joining me today from the Seeq team, we're going to have Brian Crandall, a principal analytics engineer, and our guide through the use cases we're going to be presenting. And we have Elise Bilcastro, a marketing specialist, who's going to be helping us field some of the questions and the general administration of the webinar. To give a very brief background on Grantek, we're a systems integrator with offices in the US, Canada, and India, and we pride ourselves in being a complete business solutions provider. When I say that, I mean we work really hard to look beyond just manufacturing and implementation projects and focus on the wider implications of the work we do and how it affects and improves and enables your business. A lot of our core competencies have roots within the four walls of the plant, doing process control, industrial networking, packaging systems, etc. But we've really grown as a company to focus more on interconnectivity and Industry 4.0 solutions, connecting your plant and your business systems and the cloud to enable new technology innovations that all drive back value to your business. One of our most powerful and useful tools as we develop these Industry 4.0 solutions are our strong technology partners, and we're very proud to have Seeq Advanced Analytics in our partner portfolio. More and more of our customers are asking about analytics, and we find Seeq to be an excellent tool that can bring this technology to your manufacturing process with a realistic and practical approach that fosters the development and sharing of insights in a powerful way. We don't use that term insights by coincidence. We are truly trying to drive new and useful insights from your data, whether that's figuring out what happened in the past through diagnostics, what's happening now with real-time monitoring, or what can and should happen in the future. Now, just so we understand some of the infrastructure and the background that we're going to be showing off in these demonstrations, let's go over a couple of different parts of that Seeq platform. We're going to start with Workbench. Workbench is Seeq's application for engineers engaged in diagnostic, descriptive, and predictive analytics with time series data. It's going to help expedite the analytics process from connecting historians to cleansing information and data, visualization, modeling, and calculations, and includes some features like a Google-like search on tag names, knowledge capture and real-time collaboration, and an extensive visualization tool for trending things like scatter plots, histograms, tree maps, and boundary management. The other component to Seeq is the Organizer tool, which is your application for engineers and managers to assemble and distribute insights as reports, dashboards, and web pages. You construct Organizer topics, which could include things like text, images, scorecards, and visualizations that were engineered in the Workbench application. Organizer is your insight communication and reporting platform. Now, when you get Seeq, you will have a Seeq server that runs both the Workbench and the Organizer applications. It can be run on a desktop computer, a server, or it can be scaled out across multiple server nodes. It can also be deployed on-premise or in the cloud. It's also important to note that Seeq works very well with the other tools that you use to run your business. It can export data to apps like Excel, PowerPoint, and Power BI, and its data can be sourced from some of the most popular process historians and SQL databases on the market. So that's a good background. Let's start to look more at some of the common challenges that Seeq and Analytics can help with to support your business. And we'll start with the phrase that you may have heard before: data-rich, information poor. The amount of data we collect from our manufacturing process is increasing exponentially with no signs of slowing down. But according to some of the studies, less than 0.5% of that data is ever actually used. And if our data isn't being used, then what is the point? Every day we hear about the big data and the value it brings to the bigger tech companies. We need to be leveraging and mining our own data in the same way to realize the value of what we've been collecting this whole time. It's also important to note that most of us do not have the time or money to just mess around with this new technology. We're going to be responsible for creating financial justification to invest in these solutions with an acceptable return on our investments. When we're looking at Industry 4.0 solutions, we recommend that you start with your value propositions and your pain points, then pick the right tools to solve those problems. This is going to help you stay on target and focus on the things that really do provide value back into your business. Another common challenge that we run into a lot is around Food Safety Modernization Act, quality, and regulatory compliance in general. For each of these challenges, the things that are focus areas for things like the Food Safety Modernization Act, there's usually opportunities that not only solve the issue at hand, but are also going to be able to improve your business more holistically. Now, as I start to hand things over to Brian, one thing I do want to mention is Seeq's use case-based approach and why that fits the model that I've referenced a couple of times in here so well. That use case model is going to pick a specific problem to solve, define the value to it, and walk you through the process of how you can use a solution like Seeq to create and share solutions to that problem. It's an excellent continuous improvement methodology and tool. So that's a lot of what I wanted to cover to kick us off today. With that, I am going to hand things over to Brian to demonstrate some of the successful use cases that Seeq has been developing to spark some ideas from the team on the call today. So hand it over to you, Brian.
Thanks, Sam. I appreciate the introduction and setup there. As Sam just said, Seeq does advanced analytics. Seeq does summary reports. Seeq can be applied to a wide range of use cases, as you will see. To do this, Seeq has a lot of features and functions. But through all that, there are these foundational approaches that Seeq does to provide value and insight into time series data. And this slide distills all of Seeq's functionality into what the user is trying to do. First, Seeq helps the users search for a thing. Seeq helps locate tags and assets for sure, but it also finds those times when the user wants to see a particular shape of data. For example, a certain profile, wiggle, whatever you want to call it, indicating a cavitating valve, for example. Second, Seeq helps experts quantify the results. After the expert finds something, Seeq has a means to calculate and present the final result, like an energy savings KPI in a dashboard. Third, Seeq provides ways to model what should happen in the process using first principles, a virtual sensor, or forecasting. And fourth, Seeq users can set up their analysis to monitor the process in near real time to display if the process is proceeding as expected or if intervention is necessary. So for the upcoming Seeq demonstrations, see if I can get it to click on. Grantek and Seeq have selected use cases that embody each foundation. So for searching, we will show batch comparison visualizations. For quantifying, we'll show optimizing clean in place cycles for a food manufacturer. For modeling, we will create an online batch quality prediction signal. And for monitoring, we will create a dashboard to indicate excursions from a reference profile or golden profile, as it's often called. As you can see, we have use cases that can be built off any of Seeq's foundations. So when trying to extract value from data, it's helpful to frame it in terms of those foundations. What am I trying to do? Find something, aggregate values into a report, or create a monitoring dashboard. So let's keep asking these types of questions and watch the demonstrations to see these foundations in action with the use cases. To demonstrate searching with Seeq, we will look at the batch comparison use case. Let's start at the Seeq overview screen. First, we need to find some batches. So right after I create a new workbench, I adjust the time range to approximately the time when the batches occurred. In this case, a couple of years ago. My historian has a lot of data, which is nice. And I set the display and investigate range to 1 day. Next, I know the name of the asset. It's R-401. But when I search for that term, after I type it in, it returns a lot of items because a lot of things have that name. So let's limit the search to only the assets, and I see that I have my desired asset with its corresponding children there. I click on the level tag and resize the window to get it to look the way I want. I can intuitively see the repeating signal pattern that describes the batch process, but I want to bring in a specific batch context onto the screen. Since my Seeq instance is connected to the batch historian, a Microsoft server SQL database, in this case, I can search the start-stop times, batch IDs, products, and other contextual data. Seeq presents this batch context as tags like you would find in a historian. So let me search for the R-401 unit procedures, and I'll add that to the display. This shows a nice visualization of batches as capsules in Seeq. Capsules are an important Seeq construct that are key to performing the analytics on time series data, and they represent batches very well. So well, in fact, that if you look at the capsule pane in the bottom right of the screen, I can see each batch represented by a capsule. Next, I add the duration of each batch in that capsule pane. And I will add the properties such as product and batch ID. And now I'll have a visual of many batches along with a list in the capsule pane. And now I want to hone my search on a particular characteristic of each batch. I want to examine the maximum level of each batch, which gives me that insight into the process. It's important in this case. So let me zoom in on one of these batches. And here you can see that the level has some noise in it. Let me smooth it out by going to the Tools tab and select the Low Pass Filter tool. So going down the tools, there's the Low Pass Filter. Let's call this new signal Level Filtered. Feeling creative. And set the cutoff period to 10 minutes and execute this. And notice the resulting signal is smooth with all the noisy bumps removed. Now I'll zoom out to include more batches on the display. Now I want to select those batches that are making the blue product that have a maximum filtered level less than 41 feet. I zoom out to 2 days to get more batches in my view. To select my batches, I'll use a tool called Custom Condition. A condition in Seeq is simply a set of capsules. Within this tool, I can select the batches by adding them from the capsules pane or by clicking on them directly in the display pane above. In this case, I'll select these 3 batches and call the condition blue product batches below level. And since they are making, well, let me execute it first, select them. And since they're making this product blue, I'll just change the color of the condition to blue as well. Seems intuitive. So I can select the color there. And after I clean up the details pane by removing things I don't want to see, I can get a good visual on the batches that I do want to compare. There they are. Now that I have these batches, I can click on the chain view button to see them side by side. Next, let's add some additional signals to see those as well. To do this, I'll click on the link under the Assets column, which brings up the Asset in the Data tab. Nice shortcut. And I can add the signals from there, in this case, concentration and temperature. It's interesting to see these side by side, but now let's do a batch overlay in capsule time. Here in this view, I can look for interesting characteristics and add more statistics as well. Next, I'll name the workbench batch comparison and rename the worksheet chart. Let me duplicate this worksheet to create a different visualization, a tabular representation of these batches. To do this, I will use Seeq's scorecard. There it is. and I will list the durations of each batch with their corresponding batch IDs. And here I'll add a new metric called batch duration. The type of metric is continuous, and the item we're measuring are the blue product batches below level. The statistic we're measuring is total duration, and the condition is the same as above. And there you see it. And let me modify the header a bit to be the batch ID property of the batches. So now we have this nice tabular view of a common statistic, the total time running of each batch by batch ID. Now that we've created some nice batch comparison visuals, let's put these in an organizer topic for easy collaboration and sharing. From the Seeq overview screen, I'll create a new organizer topic. I'll type a name called Batch Comparison Report, and then start dropping in my Seeq objects by clicking on the Insert Seeq Content button. I'll drop in the scorecard first, make some edits to the text, and then drop in the chart. You can edit the topic as it renders, which keeps you in that nice flow building your summary reports. And now that I'm done, let's share this topic as a PDF by clicking on the Save as PDF button. And then I can email this to the team. Or better yet, I can provide a live link to this page by clicking on the Get Link button and sharing the presentation link. This renders very nicely on mobile devices, phones, and tablets. And if there's a question about the data, such as why did that batch have a high temperature, relatively speaking, the user simply clicks on the picture and click. And Seeq opens up a live view-only window to the workbench analysis. It's completely interactive, and the user can answer the question on the spot by inspecting the data, changing the views, using all the controls. This obviates the need for another meeting or having to pull more data. I just demonstrated how Seeq is used to search for data for interesting patterns using human expertise. This is a good example of the Seeq motto, your brain, our brawn. In my experience, there is no substitute for the domain expertise like that at Grantek to find the relevant data and patterns to optimize a process, in this case, batch processes. Seeq gets smarter with usage, and humans get their jobs done faster and easier. And that is how we search with Seeq. So next, we still have 3 more Seeq foundations and use cases left in this webinar, but let's pause there to see if there are any questions from the audience. Elise, do we have any questions yet?
Yes, we actually do have a couple questions right now. The first is, how do I save and share my searches with my teammates?
Okay, great. Yeah, I can take that one. So what I just showed you was how you create an analysis. You found this pattern, you've put it in a topic, you've identified it. Seeq has built-in user authorization and authentication to be able to share things with different groups, create groups, and make sure you put it in front of the right people that you want to have it in front of. Obviously, we start from the point of view that let's liberate the data and share it as wide and far as we can, but then we can put group and security around that.
Okay, and another one. On an earlier slide, you showed some of the challenges regarding FSMA. How can Seeq specifically help us with FSMA compliance?
Okay, that one sounds like it's a little bit more in my wheelhouse, so I'm happy to take that. If you're familiar with it, FSMA covers a lot of ground, and certainly there are areas where an analytics tool like Seeq, there are times it isn't the best fit, but there's a lot of times where it is a great tool you can put into your tool belt to help solve some of these. If I were to go back to that slide, I know there's a couple of areas like MES quality management's in there, SPC is in there, and those kind of tie more back into in-process quality control and avoiding things like improper processing. And then actually one of the use cases we're going to get to a little bit later in the deck today is around golden batch, and that's going to really, and reference curves and making sure that you're detecting for deviations off of an ideal batch curve. So that's definitely one that can help around recipe management and, again, avoiding and detecting any incorrect ingredient additions. So I'm sure there are more that I haven't necessarily thought of, but yes, there's definitely direct application of Seeq that can help with things like food safety and general quality compliance.
Great. That is all the questions we have right now.
Okay, great. Thanks, team. And for those listening, we'll have another chance to do questions at the end, so please keep them coming. Great start. Okay, so let's continue with the Seeq foundations and use cases. To demonstrate quantifying with Seeq, we'll look at optimizing CIP cycles. CIP, or clean in place operations, are essential for maintaining product quality and preventing contamination. Often these operations are set on a timer based upon manual readings of the solution when the system is commissioned. This can lead to unnecessary overcleaning, since it's better to err on the side of too clean. But by using Seeq's analytics, the user can quantify savings due to reduced material costs and reduced cycle time. Let's start by quantifying in Seeq by opening the Seeq overview screen. First, I'll open the Seeq workbench for the analysis. I will use Seeq's journal feature to illustrate how we built this use case. The journal, shown there on the left, is an effective way for the experts to collaborate and share their thought process with their peers. Journals can contain text to describe what is happening in the analysis. Better yet, the user can insert links to specific steps in the journal that act as bookmarks that, when clicked, take the user to the exact place in the analysis. This includes tags, formatting, time ranges, and calculations. Exactly what is shown on the screen when the user adds a link. To display this journal in action, as an example, I'll add some tags from my asset tree and create a custom condition to create something easy to identify. There you go. And then I click on the edit on the journal and create some text. Put link here. I then highlight a region of the text and click on the Insert Seeq Link button at the top of the journal. There are different options for the links: current work step, trend items in the details pane, time ranges, and specific capsules. The current work step includes everything on the screen as you see it, and I will select that. Now watch as I mess up my view by removing everything and changing my time range to something arbitrary. Now I'm off in the wilderness. To get back to where I was, I simply click on the link in the journal and it brings me back right where I was. I will use this approach to step through this use case. But before we start, let me clean up my journal, remove that test example. And in this use case, we're going to optimize some critical process parameters for clean in place, or CIP. First, I will add my CIP phases by clicking on the first step. You can see that my phase batch objects are shown as capsules in the display in capsule pane. Next, I'll add the variables flow and conductivity. And I can see that they correlate nicely with my batch context. In step 3, I'll add the flow condition. Here you can see that the capsules align when there was flow in the CIP piping circuit. I also add the low conductivity condition. And this condition highlights those times when the conductivity dropped below the specified limit. These conditions were created using a simple value search in Seeq's tools pane. But I really want to isolate the time when all of these conditions were active, like right here. Seeq provides tools to easily perform capsule logic, and the results are shown at the next step. Clicking on step 4. This displays the condition for flow and low conductivity during CIP phases. Notice how I get exactly the desired time range on this capsule. It's during this time that I'm wasting CIP material because the conductivity is already low, so this is my potential cost savings for the material. Next, I quantify the savings by clicking on step 5. Here I show the totalized flow through the time period. As I go across the phase in time, I end with a savings of approximately 50,000 kilograms of CIP solution. Clicking on my scorecard link shows the results in tabular format. For that date, I show that the material savings and cycle time reduction and about 50,000 kilograms in 17 minutes, respectively. Now let's take that and put it in an organizer topic. This was built using scorecard and the chart from the workbench. One next step is to put dollar savings next to these values. I'm sure Sam would love to put some dollars next to these. We have customers that have saved millions of dollars per year by reducing raw material waste and optimizing batch production cycles. This use case demonstrated how to optimize CIP cycles using process data and batch context and then sharing with the team. And that is how you quantify business results in Seeq. Okay, to showcase the modeling foundation with Seeq, we'll look at the online batch quality prediction use case. The goal of online batch quality is to provide a near real-time view into the process so the operator can adjust the process inputs to save materials and time while producing high-quality batches. Currently, the batch quality is determined after a batch has completed, which doesn't leave an opportunity to save a batch that's going bad, and instead it has to be discarded. Or the energy and raw materials are being wasted on a quality that's already going to be good. After using Seeq's analysis, the yield was improved and resource costs were reduced because the experts can move the process set points while maintaining the quality that stays in the good range. So let's start modeling in Seeq. I'll use the journal to walk through this demonstration, just like last time. The first step is to add the batches and the process variables to the screen. Batches are shown at the top as capsules and process variables are in the display. I click on the second step to filter these batches for a particular product. Next, in step 3, I filter the batches more by reducing the time range to processing phases within each batch. You can see them there in the light blue capsules. In step 4, I view the training batches that will be used to create this model. This is shown in chain view to see all the batches side by side. Next, in step 5, I add the yield parameter as a bar chart. This value is taken once per batch after it has completed. This is the value that we want to see in near real time. But now you can see the data challenge in front of us here. Look at the incongruent nature of the data. We have over 10,000 samples for each process signal and only 10 samples for the yield quality. You can see the counts in the details pane. This equates to approximately 3,000 samples of data to predict one single value per batch. So how do we create a model from this? We can do it. Let's apply our process knowledge to create engineering factors that contribute to the yield and reduce the dimensions of data so that we can model a single point per batch. Acting as the process engineer here, I know that the maximum temperature reached during the batch has an effect on yield. So using Seeq's tools, I created a signal for the maximum temperature and drew that line across the entire batch. As I zoom in to a single batch, you can see that the maximum temperature was captured across this entire batch, the entire blue capsule. Let's do the same for maximum concentration and standard deviation for the level. So now I've aggregated 3 signals and collapsed all that processing data into engineering features to be used in the quality model. Notice how they each have the same amount of reduced samples through time, and as I zoom in, they continue to have the same number of samples. Next, let's calculate the offline model using our training data. The predicted quality is displayed with the yellow dashed line. Let's look at Seeq's prediction tool to show how I built this. So click on the Tools tab, and I'll modify this signal. The value to model is the yield. The inputs are all aggregated values. Some data science statistics are shown, including p-values and r-squared values to provide some feedback for model goodness. After I do the next click, we can see how the model performs on some test batches to the right-hand side of the screen. The model is off by 3% or so, but it is tracking in the right direction, so it looks good enough to deploy in our online running batches. So let's do that. When I click on the last step, Seeq takes me to the current time, and I can see that I have a running batch that is denoted by the special looking hollowed out capsule that indicates the batch is in progress, right there at the top of the screen. That indicates it's in the middle of a batch run. I use another condition called online monitor range to deploy this model to a currently running batch. Let me edit this and edit the time range by drawing on the screen. You just have to get it close, does not have to be exactly in time, but by doing that, I apply that model to that time range. And the result is the online yield prediction in the bottom lane that is continuously updated as new data is captured in the historian. Operators can use this to inform their production decisions with the goal to reduce costs and improve quality in near real time. And that is an example of modeling with Seeq. And lastly, let's look at monitoring with Seeq with the excursions from the reference profile use case. Maintaining specific boundary conditions within a process is crucial to product quality. In this case, the taste of beer. The temperature change at the end of fermentation is important, and Seeq is used to highlight deviations from the statistically good boundary. The result is early detection of process deviations and consistently good tasting beer, which is good. Specifically, the right amount of diacetyl's buttery notes. So let's show how to monitor things in Seeq. In this case, we are going to clearly highlight times where the batch deviates from a golden profile. First, let's add the fermentation batches, including the diacetyl rest phases shown toward the end of the batches. I also include the temperature and the diacetyl. Next, let's identify the batches that we want to use. In this case, the desired level is when the diacetyl falls below 0.1 ppm during the rest phase. The 3 batches at the right are identified as the good batches there. You can see them. And we'll use these to model that diacetyl level, and I'll put them in a separate condition to create the statistical boundaries. In step 3, we create a reference profile for the average and plus 3 sigma for the upper bound and minus 3 sigma for the lower bound. Switching to capsule time shows the overlay of each batch and where they are tracked as the boundaries, in the boundaries as the batches proceeded. In the last step, I'll show the batches side by side in chain view to clearly see the historical batches. Now let's apply the monitoring to the most recent batch that's in progress. To do this, I'll put the scorecard and chart in an organizer topic. I like this visualization because I can see some historical batches for context and a spark line under each key performance indicator. It looks like my current batch is at risk of poor quality as it is getting close to that lower boundary. And you can build monitoring schemes more elaborate than just a single parameter to illustrate how Seeq users can build out more extravagant monitoring topics. Here I'm showing an example of a daily meeting for operations and engineering. Current trends are shown with capsules displayed as they pop into existence. The colors of the scorecards and tree maps change in near real time to identify areas needing attention by the experts. This is how users do effective monitoring with Seeq. And that concludes the demonstrations of the Seeq foundations and related use cases. As you work with Grantek and Seeq, bring your use cases and also frame it in terms of what are you trying to accomplish? And we can quickly get you that valuable insight from your process data. And now, to close out the webinar, I will hand it back to Sam. Sam, back to you.
Okay, great. Thank you, Brian. So to briefly summarize and wrap things up before we open it up for more questions, as you've learned, it's a powerful tool for helping to turn your data into information that can be used and useful in continuous improvement initiatives. We're going to always recommend starting with the problem and identifying the value to it, and then finding the right tools, techniques, and solutions to try to address those. Now that you're a little bit more familiar with Seeq and its analytics platform, it might be the tool that you've been looking for to solve some of the problems that you've already identified. Realistically, if we get started soon, we should be able to have some real use cases and results by the end of this calendar year. So if you do have a problem in your manufacturing processes and you think that Seeq could be a part of the solution, I'm glad that you were able to see it today, and I'm looking forward to hearing from you. Please don't hesitate to reach out to the team with some of the information that we're going to have here at the end of the webinar. And with that, Elise, I'll kind of open it back over to you if there are any other questions or things that we want to cover before we wrap up today.
Yes, I do have a few questions that came in. The first is, how many users can use Seeq at one time? How does it scale?
Yeah, I'll take this one, Sam. So Seeq is built to scale from very small projects and teams to thousands and thousands of users across large enterprises. So whatever problem you're trying to tackle with your historical data, your time series data, Seeq and Grantek can find just the right fit for you to scale to meet your needs.
Excellent. The second question I have, what if I have a data source that isn't listed as supported by Seeq currently?
Yeah, good question. So, Seeq, we list on our website a lot of data sources, historians. Sam even highlighted some of those on the architecture slide. And we find there's always something out there that is not listed. Maybe it's a custom development. Could be a data lake development that was built, and the company has their data in that data store. And the short answer is Seeq connect to it. We pride ourselves on being able to connect to it. We have a software development kit that has all the basics, basic plumbing ready to go to be able to pull that data out and do analytics on it. So if you see something that is not listed, we can get to it and build a connector to it.
Yeah, and maybe I'll even elaborate on that a little bit. So Grantek has had a little experience with this as well. It's probably good to note that, yeah, I mean, Seeq is very flexible, and there are definitely ways that you could program it to pull data from a variety of sources. But in general, it's extensible like that. We've done a project where we wrote in a custom connector into a SCADA system to be able to show warnings right there on a screen to other users and things like that. So it's a pretty open platform. There's a lot that you can do with it. Certainly the things out of the box are really helpful, but if it's not out of the box, it's still worth having a conversation about.
Thanks, Sam.
Yeah, thank you both. That wraps up the questions right now.
Oh, we got off easy. Okay, well, I'll go ahead and close this out then. I think we have one other slide in here just to show a couple of our contact information if people do need to reach out to us. Hopefully you have a couple of contacts at Grantek and Seeq that you can reach out to if you have any questions, but if not, there's also a couple of emails in here that you can reach out to get more information. So thank you everybody so much for joining us this morning, evening, or afternoon, depending on where you're at. Looking forward to hearing from you all, and you have a great rest of your day.